Plug in and the car says charging interrupted. No lights, no charge, and you're standing at a charger wondering if the car or the network just betrayed you. Today we are going inside the messy, visible world of software handshakes and protocol quirks that leave BYD owners rebooting chargers, unplugging cables, and calling support. I'll show the error messages people actually see, why non-native chargers sometimes refuse to work, and one simple sweet spot strategy you can use for daily top-ups that avoids most of this drama. Stick around, the fixes are part of technical, part habits, and part politics in the charger ecosystem. When you plug a charger into a modern EV, a lot happens in the first few seconds that you never see. The car and charger exchange digital messages, identity, capabilities, allowed current safety checks, and billing info. This handshake uses standards like ISO 15118 for smart charging or simpler pilot signal methods. But every implementation has little differences. That's where things go wrong. BYD owners commonly report messages such as check OBC system, charging interrupted, or charger not recognized. These aren't random, they point to two families of problems. One is software or protocol mismatch, which the car and charger disagree about the handshake and the charger stops the session. The other is hardware layer, an intermittent contact or arcing that translates into a digital fault and halts charging. Owners talk about repeated reboots, removing and replugging the connector, or using entirely different chargers to confirm the issue. These user reports are frequent across forums and owner groups. For example, multiple threads document check OBC system, appearing while charging on AC public chargers or Type 2 level home units. In some cases, BYD support points to charger compatibility or cable issues, but owners report different results across charger models. One charger works fine, the next throws the same error. That inconsistency is classic of communication level mistakes or marginal electrical behavior. Another pattern after a software update, some BYD owners notice new interruption behaviors. Charging stops after a short time or sessions fail to start entirely until the car or charger is rebooted. These kinds of post-update glitches have been reported in owner groups and social channels. And in some countries, manufacturers actually rolled hot fixes to address handshake bugs with certain networks. That tells you the problem lives firmly in the software and protocol land as much as hardware. Anecdotally, users report the classic troubleshooting loop. Try charger, get error, unplug and replug, reboot car screen, retry, call charger support, wait 20 to 40 minutes, finally swap to a different charger or cable, and it works. That wasted time and the anxiety of a charge that might fail when you need it is the consumer visible cost of fragile interoperability. Owner communities have compiled lists of chargers that inconsistently work versus those that often fails for BYD car, which shows the issue is real, repeatable, and not only in a handful of isolated cases. So why does this keep happening? The EV charging ecosystem is fragmented. Many charger hardware vendors, multiple networks, different firmware versions, and evolving standards like ISO 15118 or CPP, vendor-specific quirks, are impacting this. A charger that implements a feature slightly differently can cause a BYD car to misinterpret the handshake and stop. And on the hardware side, connector wears, pins get dirty, or cheap cables introduce resistance that lead to arcing. The charger stops for safety. Combine this with aggressive software timeouts and you have a recipe for interrupted sessions. Beyond the technical mess, there is an economic angle. Many public chargers are older or run firmware that rarely gets updated. Charger operators often have thin margins and don't prioritize compatibility debugging for every EV model. So even when a fix exists, it may not propagate quickly to all stations. That leaves owners in a patchy world where reliability depends on whether the specific charger you pull up to has been patched recently or not. What specifically breaks? Here are the common failure points from owner reports and technician notes. Explaining simply, communication mismatch, digital handshake fails, the car and charger can't disagree on protocol flags, like smart charging features, billing tokens, or expected pilot timings. Result, charger refuses to energize or stops shortly after start. Reports show this is often the first suspect when errors like charger not recognized appear. Example: after a firmware update, a BYD model in Europe briefly failed to negotiate with some CCS or Type 2 stations until an engineering update rolled out. That's a case where the software fix fixed the compatibility issue. OBC and AC charging edge cases. Check OBC system occurs when the vehicle's onboard charger detects unexpected voltage, current, or signals. Sometimes this is the car being protective, sometimes it's the charger's fault. Loose or contact issues and arcing. Physical connector problems can create spikes and then digital faults. Many owners' threads shows sessions failing at the same connector spots across different chargers, a sign of wear or contamination. Scheduling and sleep state conflicts. Cars that sleep to save energy can miss or mishandle scheduled charging starts when charger wake up signals aren't consistent across networks. The result is didn't charge overnight and confused owners. Community threads show scheduled charging failing in a new way that points to charger car sleep or wake mismatch. Those are the technical causes. The user experience cost is measurable: time, anxiety, and the occasional tow if you rely on a single charger for a long trip. The fleet operators and ride-hailing drivers often quantify this in downtime times. A small failure multiplies into lost revenue as well. Here's what matters most: you can't fix the whole ecosystem alone, but you can change how you interact with it so most of the pain disappears. Owners are least likely to run into troubles. Use a simple sweet spot approach for daily charging that minimizes exposure to flaky public chargers and software handshake fights. Sweet spot is rely on scheduled level 2 home or workplace charging for daily needs and reserve DC fast charging for true long distance needs. Why this works? Level 2 chargers use simpler, often more reliable AC charging handshakes and are under your control. They're less prone to handshake or firmware mismatch drama seen at the public DC sites. Data and guides show level 2 chargers typically deliver 3.3 to 7.2 kilowatts, which is around 30 to 35 miles per hour at the high end, which covers the typically daily commute needs easily. That means you don't need a public fast charger every day if you schedule charging overnight. Daily energy needs are modest. Most commuters use roughly 10 to 20 kilowatt hour per day, which a typical 7.2 kilowatt level 2 adds in about 1.5 to 3 hours. Use your car's scheduled charging to start in the cheapest off-peak window and avoid both time of use penalties and dodgy public stations. Using a home level 2 or workplace charger reduces exposure to public network software bugs and saves time on wasted troubleshooting. Here's the digit by digit example to make it concrete. If your commute consumes 12 kilowatt hour a day, a 7.2 kilowatt level 2 will add 7.2 kilowatt hour in 1 hour. So 2 hours overnight gives you 14.4 kilowatt hour, more than enough. That removes daily dependence on public chargers and charging interrupted. Source materials from utility and EV guides show these level 2 numbers and practical ranges. Here are some practical fixes, what BYD owners do right now. You can't wait for every network to be perfect. Here's a practical checklist owners use today. They favor scheduled level 2 charging at home or work for daily top-ups. Set the car to start charging during your local off-peak window to save money and avoid public stations drama. Level 2 chargers are simpler and more consistent. Keep a list of chargers that consistently work with your BYD model. Community forums are gold mines for this information. When traveling, prefer networks that community feedback recommends. Update both car firmware and, if you control it, charger firmware. If BYD issues a hotfix, install it. Some owners report problems disappearing after updates. Likewise, chargers that get firmware updates fix handshake quirks. If a charger errors, try a different connector or replug after a short wait. If that fails, move to plan B, another charger in the station or nearby. Don't sit and keep retrying. Many owners wasted 20 to 60 minutes doing loops that quick switch would avoid. Use a certified portable EVSE for guaranteed AC fallback. It's slower but reliable. For apartment dwellers, get landlord consent and install dedicated circuits to avoid risky DIY hacks. BYD charging glitches are painfully because they're often invisible. A tiny software or protocol mismatch or a marginal physical contact becomes a user-facing charging interrupted message. The fault may live in the car, the charger, or in the handshake between them. Owners report and community threads show this is a recurring problem, not a one-off. The practical high retention strategy for daily life is the sweet spot. Schedule level 2 overnight or workplace charging for daily miles, and reserve DC fast plugs for long trips. That minimizes the exposure to public flaky software. Avoid the reboot, unplug, repeat loop, and keep your life moving. If you own a BYD or are thinking of buying one, take these steps. Set up a reliable level 2 charging where you are parked. Join a local owner channel to learn which chargers are dependable and keep your software up to date. And the ecosystem will improve. But until it does, your habit make all differences.